Welcome back. Today's problem looks simple, but it'll make you pause. What is the derivative of x to the power x? At first glance, you might try the power rule. d dx of x to the n is n times x to the n minus 1. But that only works when the exponent is a constant. Here the exponent is x, so this rule doesn't apply. What about the exponential rule? d dx of a to the x is a to the x times log a. But that needs a constant base. Our base is x. Doesn't work either. So we need a different approach. Let's get creative. We'll show you two different ways to crack it. Method 1. Logarithmic differentiation. Take the natural log of both sides. Log of y equals x times log x. That's the log power rule. Now differentiate both sides. Left side, d dx of log y, chain rule. Derivative of log is 1 over y. Multiply by dy dx. So the left side is 1 over y times dy dx. Right side, d dx of x times log x, product rule. F equals x, g equals log x. F prime is 1, g prime is 1 over x. Product rule, 1 times log x plus x times 1 over x. X times 1 over x, the x's cancel. That's just 1. So the right side simplifies to 1 plus log x. Set them equal. 1 over y dy dx equals 1 plus log x. Multiply both sides by y. dy dx equals y times 1 plus log x. And since y is x to the x, dy dx equals x to the x times 1 plus log x. That's our first answer. Let's box it. Now method 2. Completely different approach. We use the identity a equals e to the log a. So x equals e to the log x. Raise both sides to the power x. X to the x equals e to the quantity x log x. Now we can differentiate. We have e to a function. Chain rule for exponentials. d dx of e to the f equals e to the f times f prime. The exponential stays. Multiply by the derivative of the exponent. What's the derivative of x log x? Same product rule. X times 1 over x plus log x. X times 1 over x cancels again. We get 1 plus log x. So it's e to the x log x times 1 plus log x. And e to the x log x is x to the x. Same answer. Both methods agree. Let's review the theorems that made this possible. First, the log power rule. Log of a to the b equals b times log a. This is what let us convert x to the x into x times log x. Without it, we couldn't start method 1. Next, the chain rule. The derivative of f of g of x is f prime of g of x times g prime of x. We use this twice, on the left side to differentiate log of y, and in method 2 to differentiate e to the x log x. The product rule. The derivative of f times g is f prime g plus f g prime. This came up in both methods when we differentiated x times log x. It's where the x's cancelled. The exponential identity. Any positive number a equals e to the log a. This simple fact is what powers all of method 2. It let us rewrite x to the x as e to the x log x. And finally, the exponential derivative. d dx of e to the f of x equals e to the f of x times f prime of x. This is the chain rule specialized for e. The exponential survives, and we just multiply by the inner derivative. And with all those tools together, we arrived at the same answer both ways. Here it is, one more time. The derivative of x to the x is x to the x times 1 plus log x. Two paths, same result. That's how you know it's right. The log method is mechanical. You can apply it to any tricky exponent. The exponential method shows the deeper structure. X to the x is really e to the x log x. Next time you see x in both the base and exponent, you know what to do. Thanks for watching. See you next time.